Okay, my name is Philip Di Melo, and I'm a data scientist working in public health informatics and technology, clinical informatics, and biomedical computing. I will start a series of lectures on public health informatics and technology that I conducted at Bowie State University College of Arts and Sciences, Computer Science Department. The training was supported by Workforce Development Program by the Office of National Coordinator, and I, on behalf of my students, I would like to thank them for supporting the training. We decided to put this on internet, these lectures, because we found out that the interest to public health informatics and technology, we just abbreviate it as FIT, is very high. Why? Because first of all, this area is very important, and it will move public health and life standards of our citizens higher. So this will have very positive impact on communities, on population in general. And second, why it is important, because this field is on the intersection of various disciplines. For instance, computer science, information theory, data analytics, mathematics, public health, and so forth. It makes it very attractive. However, recent pandemic, COVID-19, showed that we have some weaknesses in this area. And what weaknesses are? We say that there are 4 weaknesses. Let me just write it down. Number 1, incomplete data. Incomplete data. Incomplete data. Incomplete data leads to inaccurate results. And in public health informatics and technology, we have a number of different sources. But we cannot say that we all the time get data from some sources. For instance, social determinant of health. Okay, this is a problem which many people working on, and I hope this problem will be solved somehow. Second is data quality. In computer science, there is a theorem that says that doesn't matter what kind of algorithm you are using, it can be very powerful, but if the data quality is poor, okay, you will never get an accurate result. And we actually, why it is important for us to have good quality data? Because we work in public health, and of that, we actually, as we understand, this pandemic caused us lots of damages. We had, even it is causes threats to national security, national economy, unemployment, and even lives of our citizens. So therefore, this one, we have to take care of data quality. And there is the whole environment, the whole paradigm, how to improve data quality. Okay, this is very, very important. We are going to teach you how to boost data quality. So you will know all these approaches that are available and you have to know them. Okay. Number 3, another weakness. Number 3, it is fast data. One of the problems, one of the challenges in public health informatics and technology, that the data come in high velocity. We work with big data. But plus, we also need to collect the data in the fastest possible way and process the data in a very fast way. So this is very, very important, is to have fast data, to accelerate the data collection and data processing. Okay, because of that depends the whole efficiency of the use of public health informatics and technology to, for instance, mitigate or to get better preparedness or just to curb the spread of pandemics, for example. Right. So this fast data. Number 4 weakness. We do not have enough free data flow from one organization to another. So if, for example, I would like to get data and store them in public health agency repository, and I have many, many sources we will discuss next lecture on public health sources for public health informatics and technology. Okay, then we have to have the so-called free flow of data. It is interoperability. So for interoperability. And lately, we started to use a fast algorithm for data interoperability, which is called FHIR REST API. So we will talk about interoperability the whole lecture, and I will explain you what does it mean FHIR, what does it mean REST, what does it mean API. So now do not be frustrated if you don't know this. We will cover everything, okay, on that, and you will see, even in hands-on training, how we work with this magnificent tool, okay, that makes lots of things that we had before prior pandemic are resolved. But today, what I want to do, I want to talk with you and explain to you web services. What does it mean, web services? Okay, web services. Web services equals API. So any web service is API, but not vice versa, because we have APIs which are not web services. Okay? So before going to discuss API, I would like to say that when you start working with web services, first thing what you have to do, you have to find out, you have to build the URL. And what does that mean, URL? URL is universal resource locator. It's like address in internet. So for instance, any website has URL. Yeah. And this is like address. For instance, suppose my address is in Spring Valley Street, number 1300, let's say Baltimore, Maryland, and my zip code. Okay, so this is address is sufficient for a mailman to bring me all my correspondence. Same thing, we need to get the address and in internet, and this is URL. Okay, now how to build URL? I will just teach you how to do that. I will teach you on an example. Suppose I would like to search for some information on internet that's related to virus, for example. So I want to find information about virus. Okay. So what I have to do in this case, first of all, I have to put here HTTP. HTTP, it is Hypertext Transfer Protocol. We will discuss it in more detail because it is it's a whole structure of HTTP. But the bottom line is that if I put my request here in the body, because HTTP has body, for instance, virus, it will bring me somewhere. This text will bring me. I can put not only virus, but I can put sentence, I can put anything I want. And this will bring me somewhere. Okay, but if, for instance, I travel from DC to Baltimore, I can take a plane, I can take a car, I can take a taxi, Uber, for instance. So in other words, I have to give the HTTP some knowledge how it will travel. And in this case, I will just put column / and put here www. It is World Wide Web. So this HTTP will send my request via internet. Okay, sometimes we have HTTPS here. S is just additional security, same thing. So HTTP or HTTPS, it will go over internet. Okay, but internet is, is very big. I have to give address. So for example, the number of my building, number of my house. So for this, I have to put here dot, and here I put Google. Google.com. Google.com is a server, so it will travel to my server, not my server, but to Google server, okay, from my computer. Okay. Now, the server consists of different domains or cells. It's like a beehive. Okay, so each cell has some functionality. And of course, I have to send my request to functionality that will do search for me. So I have to put here / I have to put here search. Don't forget to put here question mark. So in this case, it will go right to the cell with this functionality search. Okay, but it's not enough, not complete, because I have to give a parameter. We call this parameter in URL. What actually this search will do. And we have to put here Q, which is query, equals my word. It is virus, this one. Put virus. What is fabulous that this URL, okay, that I give, it will execute my command, my request, and will bring also by HTTP back the response. It can be data, it can be text, it can be images, anything I want. Regarding images, it is very easy to put here image, for instance. So for image, I have to put here TBM. TBM is to be matched equals image ISRCH search. Then I have to put this sign, which is and then I put Q equals virus. So this command, this URL, will bring me back via HTTP information about viruses plus images. So different images like COVID, whatever, flu, it will bring me images. Now, what I would like to tell you. I would like to tell you about API. So API it is application. Okay, it can be for instance software. Okay, that will search for me the word virus information related to virus. P is program that will run this application. Yeah, and I is interface. Why I put here in red marker computer? Because it belongs to me. So interface in this case belongs to me because request came from my computer. But application belongs to Google and programming part belongs to Google that will run this application when my request will come through. Okay, so what does it mean actually, API? I will just give you an example. Suppose you go to a restaurant, okay, and you would like to order some food. Let's say I like Chinese food. I go take my wonton soup and rice, chicken wings with rice. Then I have to give this order to the waiter, and waiter is programmed to bring not programmed, but ordered to bring my order to the kitchen, okay? And he will bring me food. So first of all, it saves lots of my time, and I try to do it every Sunday. Why? Because if I go to a restaurant, I don't need to go to a supermarket to buy food, then to come home, and then to start cooking and so forth. And then I finished my Sunday, so I didn't go anywhere. And this is exactly what happens when we use API. It will save us lots of time. So we talk now about, you remember I said we have weakness number 3, it is fast data. This accelerates API, the data retrieval from one place to another. Okay, now because I do not need to write a program like what I showed you, ETL, staging, targeted data repository. For this, I need program. Here, I received anything without any knowledge how, for instance, that database is built, how this is programmed, how it is data structured, maybe structured in such a way that I cannot, my program cannot handle it, yeah, because data have different structure. It can be structured, semi-structured, unstructured. We'll discuss it later. So I have lots of things to do prior programming to find out how that data repository, how the data are presented in the data repository of the source. In this case, I don't care. Same thing when the waiter bring my order to the kitchen, I don't care. if the cook is Chinese, or he is Japanese, or he speaks English, he doesn't speak English, what kind of ingredients he put and so forth. I don't want to know this. So how many minutes it will cook, I don't know. He will bring me food, which I like, and I won't spend any time on cooking and going to supermarket, okay? The same thing, when I use API, I can retrieve data and information without knowing anything about the data, about where the data, how the data were placed in the database, what kind of database, how the system was programmed, and many other things. Okay, so I don't want to know this. I will just need URL, and with API, I bring it from one place to my computer, to my disk. Yeah, in the case of search, I will have it here before my eyes. Now, what I want to tell you something, that what does it mean HTTP and API? Are they different, or maybe are the same? Actually, it's very, their role is very similar. So HTTP will bring to google.com for searching word virus and bring it back. And API also doing. But API actually is a system that controls HTTP. Because, for instance, let's say, I'll give you this example. So I'm in the Chinese restaurant, and I would like a Chinese waiter to bring me Italian food. He says, or she said, we don't have that. Spaghetti, something, or pasta, or ravioli. We don't have that here. Okay, so API, same thing is doing with HTTP. It makes sure that what my request can be executed. Okay, that is what API is doing. It's like a menu. It is executable. So it is chest everything, and then it brings, if it is executable, is bring my request to the google.com, and from google.com takes all the search for viruses or any images or whatever I want and bring me back. So this is the role of API. Now, I would like to say one thing. In clinical informatics, in clinical medicine, we would like to clinical medicine, they try to cure, and they cure a patient. Yeah, the objective is to cure a patient. Suppose now a person, he drove a motorbike and he fell and injured his knee, for instance, like that. And he's admitted to hospital, and the system, HIS, this hospital information system, starts to work. We will also discuss what does mean HIS. And it starts working. Okay. It puts all his, for instance, X-rays, radiology, lab tests, and ATD. So we'll discuss it, everything. But public health does not cure people. Public health tries to protect, okay, to prevent. So prevention is the word for public health. So in this case, if a person fell and injured his knee, public health would examine why he fell. Why? What happened? Why did he fall in that place? Maybe it was not enough light in the dark. Maybe he doesn't, his motorbike is old, and many other things. Okay, so therefore, in public health, we have many question marks and many sources that will help answer these question marks. Okay, so suppose now a healthcare provider would like to know something about this patient. He will use this API, for example. He goes and he gets right away his records, because his records, maybe they have this unique URL. Okay, this will be very helpful for healthcare provider, for doctor, yeah, or a nurse. But you know, if we have public health, we'll have so many organizations. Suppose I want to know how many people in our county, in PG County, they came to ER, it is emergency room, with high fever. So I have to examine many hospitals, not only one. Okay, clinics, hospitals, healthcare provider, private clinics, you know, to find out about that. And imagine that I start preparing algorithm programs for each organization, because each organization might have different way of preparing, of storing the data, and different way for us to retrieve the data. So we have to know how this information system that stores the data and may release the data, very, very important, works. Okay, and what the data, how they're structured. Is there a text, unstructured, or it is relational database? They put something like, for example, vitals. So I have to know everything. But if I have URLs of each source of data, then it will take me seconds, not even minutes, to get all necessary information. So it's a great, great, great step ahead if we want to deal with fast data, and we want better respond to future challenges. So this is web services is a step ahead, and a tool that would help us better respond to future challenges. Now, one thing I would like to tell you, and we call this, we have a term, mashup. Mashup Mashup, what it does, we have a unique APIs, but in mashup, we invoke APIs from different systems. Okay, I'll just give you an example. Suppose you would like to travel from, let's say, Washington, D.C., you would like to go to Miami in Florida. So you go to internet and you just take some URL of, just put there something like travel from DC to Miami. And what you will have a number of different airlines. I'm sure you had this experience. And this is very, very similar to what we have in public health. We have different sources. So imagine that airline each as a source. And so we have one API that invoked for me different APIs. So then I go here. For example, if I like this ticket, I think it is it takes off at 10 o'clock, at 10 a.m. and it doesn't cost much money. So this one is better, because this one, for instance, takes off at 4 a.m. and it's not so good. So it's a little bit more expensive, but it departs at, let's say, 10 a.m. So for me, it's better. So what happens, I actually eliminated, I used this one, API, then to buy the ticket. So I will just tell you. So I had API that brought me to a combination of APIs. Then I look at this and I take this airline and its API buys me a ticket. This is called mashup. Okay, very, very important. So what happens is in public health, we can have also, I don't know, a number of APIs, for example, in mashup. And I can have various possibilities, various sources, and so forth. Now we have a criterion here that, for example, I don't want to depart at 4 a.m. in the morning, no way. And I will pay a little bit more, but I will depart at 10 a.m. Okay, so it's very, very distinct, very clear, the method that I use to choose between different APIs, and I buy a ticket. What I will do in public health? In public health, I have many sources, but I have a wonderful tool which is called feature engineering. Feature engineering. And feature engineering is based on machine learning that will help me to choose what kind of source of data is more important. So in this case, with airlines, I just eliminate everything. And I take this one that departs at 10 a.m. and costs $200. Okay. But in public health, it's a little bit different. I can eliminate, for example, some features, and some features I will leave using machine learning. So for us, I will just make a conclusion that one of the possibilities to go on and move forward this area is to use API, mashup, and feature engineering. So this is a possibility to tremendously accelerate our work that we face it every day in public health informatics. Okay, so what I want you to do as a homework. You go to postman.com. Postman.com, and you create your account. It is absolutely free. You don't pay anything. Okay, when you create your account, just punch in the Windows search. It is called new request. New request. In new request, what you do, you build, for example, in it is called get, and here is Windows. There is also post. Post is to send the data. Get is to receive the data. It's like HTTP. So don't do any post now because we will discuss it later. In get, you put any URL you want. For example, HTTP / it is Amazon.com or eBay.com or Google.com. This is your URL. For instance, put www.google.com and here put HTTP. Okay, so you put this URL here, and then you will find something, what you will get the result. And this is interesting, and we will discuss with you next time. All right, so we finished for today, and I think you learned something, and we will continue next lecture with postman.com. Then we will cover also EHR and other public health sources, including registries, including healthcare data and other things. Okay, bye-bye.